Okay.
Power Museum.
All right, it's live, so. Time to put your phones away for the lesson, please.
Where I'm watching.
Yeah, no, you're not. Put your phone away. Put your phone away. Because I believe this does a pretty good number on a screen.
I've been hit by a screen.
Yeah. Yeah, I think that'll kill a screen.
Yeah.
So, anybody up for taking?
I watched the
You're
video.
buying a new one.
No, it's because you're dumb enough to get your phone out, so. All right. Ah, damn, I almost thought I had everything ready. I forgot. Don't pull your phone out, though. No. Measuring tool. That's why I love having these toolboxes right here. Okay, so micrometers. You'll need 2 of them for your assignment today. Mike, put your phone away, not hide it behind your leg. So we have 2 of these. The other ones will not be needed. You won't need a 3 to 4 or 2 to 3. Okay, just these 2. So the last time we met, which was Friday, we didn't do anything. So Wednesday was the last time we met in shop to do something. And that's when you guys removed the various parts from the motor. Okay, so what part is this one?
Crankshaft.
Crankshaft. Camshaft. Tappets. Valves, yep. You're doing really good. Piston, and there's a couple different things you were supposed to take a picture on here, right? Our connecting rod, our actual piston, and then the piston rings. So which one is this one down here? Which ring is that? The oil ring. And how do you know it's the oil ring? Yep, it's got the grooves, or the waffle. Okay, and then we have 2 compression rings, which are solid. Right? Now, when we go to put these pistons back in, one thing I want you to pay attention to, as soon as it focuses, is the compression rings. So obviously, to get it around the engine, you have to do something particular, right? You have to expand them and put them on. So they have a groove or a cut in them. Okay? When you install these pistons, none of these grooves or these cuts need to line up, because that means compression can now leak past that. Okay? So you're going to make sure that they are at least 180 from each other, so opposite sides of the motor. So that way, one side is compressing to the other. Same thing with the oil rings. You want to make sure that they're not lining up. You can see the gap right there, so I'm going to move the compression rings. So everything's kind of clocked to the 4 different directions on this piston. Okay? So we're going to make some basic measurements today. We have this one right here. What is this tool or part?
Push rod.
Push rod. That's what sits on the tappet. Come on, focus, camera. I need more contrast on my table. Orange on brown doesn't work. Oh, white. There it goes. So the push rod sits into this little pocket on the tappet, and then this push rod then goes up to the rocker, which then pushes up on the rocker, which then pushes down on the valve, which then opens it. Okay? Now we have a lot of measurements to make, and that's why you guys made a bunch of different pictures. Gentlemen, if you want to speak, leave. Okay? I think other people would like to know what they have to do for today's assignment. So, if you want to speak, just leave. There's nothing stopping you. I'm not going to bar you from leaving that door. Okay. So, the first thing I want you guys to work on is the camshaft, which is probably one of the harder ones to measure. Because I want you to measure what's called the dwell. Dwell is referring to time. Okay? Time that the valve is open. Now, when is the valve open? When the top of the lobe. Okay, so if you look, you'll see, I'll go to this one. You can see the lobe is taller than the main circle. So as the tappet rides, let's see if I can get it all in image, trying to hold everything at one time, rides on this lobe, as it turns, it's now pushing the tappet up. Okay? So from 0 here to up here is our dwell time. Okay? That's referred to time because as this rotates, it consumes time to do that. Okay? As your RPMs go up, the dwell time would shorten because it's going faster. But we need to know that distance. So we know how far this valve is going to open based off of various measurements. What we are doing is called blueprinting the engine. Okay? So the first thing I want to do is I want to measure the dead section of the lobe, or the closed section. So that is here. Okay? From one side to the other side. We'll set that up. I'm going to have now my micrometer. I have a analog readout on mine. Being the teacher, I get the better tools. So as I turn it, you can see the dials reading. It also is still readable here. Okay? And we are going 3 places past the decimal point on all your math. Now remember, depending on which micrometer set you have on the table, you're going to turn here or here till it ratchets. This one, it's here, and you can hear the clickety-click-click. So I'm going to open it up. Now I'm not going to spin it around like this, right? Because that then bends everything. I'm just going to untwist it. Okay, give me a second. Okay, so I'm going to set up the cam with the lobe away from me. And I'm just going to keep opening it until it passes. Trying to get it to sit. This is where it's nice when you have your teammate help you. So now I'm going to turn this until I hear the click. Okay, that's as tight as it's going to go. If I go with this, I can make it tighter. But I am now denting the cam. Okay, so use the ratchet. Now I can remove it, and I can make the reading. Now, I'm going to skip the numbers. I'm going to go to this. So if you remember the math, let's hear it. Come on. We have 8, right? So 0.8. How many lines do you see past 0.8? 2. So that would be what? 50. So 0.850. Okay, now we look at this long line. Let me grab a pointer of some sort. Here we go. That line right here, I'm going to follow it down. I'm drawing on here. So there's 15, 16, 17. So 17 plus 50. Really, guys? 67. So 0.867, right? So it's just about there. There we are. 0.867. Okay, so I'd write that down, and you have to add that to your PowerPoint that you are creating. Okay, so which lobe was that I just measured?
The exhaust.
The exhaust lobe. Very good. Because it has the exhaust release right here. Okay, so that's that side. Now I need to measure the tall, right? Now, if this is almost an inch, do you think I'm going to use this one again with my 0 to 1? No, so it might be more than an inch. So I'm going to grab my 1 to 2. Okay, and when I close this down, because this one will go negative, there I am at 0. Well, it moved. Okay, and then my dial is reading 1 inch. Okay, that gap is exactly 1 inch. So now I'm going to sit here and I'm going to measure the peak of that lobe. Okay, there's my clicking. I'll remove it. I got my finger covering the numbers. Okay, so what do we have? 0. Okay, so nothing there, so that's 0.0. And then we have 3 lines, right? So that's 0.075 plus 15. So 75 plus 15, 90. So we have, how would you write it out? No, we got to start with the 1 because this is 1 inch. So 1.090. There you go. Okay? So I've just measured the exhaust lobe height. Now the difference is the rise. Okay? And we can measure that and we're going to go, okay, what was the difference? I don't even remember what the previous number was. So you will have it written down so you'll know the rise. And then you're going to translate that when we put it all back together to see how far the valve actually moves down, because the rocker will change that. Okay? All right. You're going to measure your your crankshaft. You're going to measure these 3 journals. Now, do you remember what they were called? So this is your PTO, power takeoff. This is your crank, or connecting rod journal, connecting rod. And then this one's your magneto journal. And how do I know the difference? The magneto has a taper. The PTO side has the step, and then you usually see it's rusted or dirty, because that's the side that sticks out of the motor, where you would tie your lawnmower blade, your pump, or any of that stuff for this motor. Okay? So you're going to measure those 3 journals. You're going to measure on the camshaft not only these lobes, you're also going to measure the bearing on this side and this side. Okay? You will also measure your valve. Let me show you that one. So once again, I'm not going to use the 1 to 2 because that's too small. I am going to use my 0 to 1 inch. I'm going to go ahead and close that down. Okay, now on the valve, because it is a cylinder, I need to know a few things on this cylinder. Okay, first thing I need to know is if it is still round from here to here. How would I do that? Thank you. Well, I'm going to measure one direction, this way, and then I will measure this way. And that way I will know if it's round. Because as it wears out, it will go egg shape or oval, like the lobes on there. Okay, so I'm going to set this down. I want to measure down here near the base, not all the way. You can see the step right where the pencil's pointing. I want to measure just above it. And I'll record my measurements. So this one, 0.215. I'm now going to turn the valve 90 degrees and make my measurement again. Did I get the same numbers? Yeah, so that means that part is still circle. Okay, now let's go up here. I don't have the same number anymore. So it's not the same roundness as the base. Okay, so let's go ahead and now I'm going to turn it 90. And this one is. So it's slightly egg-shaped. Ever so small. What was it? 0.000, 3 zeros, and then a half. So 0.0005. Okay, now I'm going to come up here near the top. That's a big difference. Okay. Turn it 90. So this valve has some problems. By being egg-shaped, what can happen? All right, so as the valve goes in the valve guide here, okay, the rocker is pushing down here to make this valve go up and down. Just really fast, right? But if it's egg-shaped, that means that this valve is being pushed over, which then is deteriorating the valve guide, that hole way down in there. And if that hole is gone out around, that means that valve is not seating correctly, and you will have problems. Okay? So that's why you have to measure all these parts. So you're going to measure the valve. How many times? 6 times, because you're going to do both sides. Okay? Tap it. You're going to measure it 4 times because the shaft is not as tall. Okay? But you can see the wear, because it also goes in a guide, and you can see the wear, I don't know if the camera's picking it up, right there. Just like this valve. This was out of a racing motor, so you can see the wear here, and especially here where it is really out around. Okay? So, you're going to measure your valves, you're going to measure your tappets. I want you to measure your push rods. Okay? I will give you a caliper. There will be one caliper for the whole small engine slab. That's to measure its height. Make sure you know which one was your exhaust and which one's your intake. Okay? You're going to measure the diameter 6 times. Okay? So here and then here. Here, 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 and here. Okay? And then the length. Okay? The last thing I want you to do with the push rod, and I'm going to try to do it here, is you're going to see if it is still straight. Let's see if I can do it. It's easier if you do it on paper. Okay, that's how you check rollers in drafting, if they're still straight. I want to pick a point, so I got my Sharpie. I'm going to call that top. Okay, let's see if I can get it. Okay, you can see that mark as I roll it over. Okay, I'm going to call that top. Now this happens to be a soft lead pencil, so it should work. I'm going to hold that still, and I'm going to draw a line down on a piece of paper. Okay, and I know this is my exhaust, so I'm just going to put EX. Okay, and now I have my line, right? Now what I want to do is I'm going to take that mark, and I'm going to flip this, because now what will happen? This is the side I originally drew my line on, right? Now it's on the opposite side. So I'm going to line it up again. And the trick is you put your pencil down on your line, and then that way you can now roll the pencil into place, and that way you get the same spacing as the pencil how you drew. Okay? I'm holding it in place. My mark is at the top, and this is going to be kind of off because of the wrinkle of the paper. And I'm going to draw another line. Preferably if you have colored pens to do it in a different color. Okay? And then I'm going to look. And let's see if I can get this really close in here. There is a spot that is off. I don't know if you can see it, but it's right there. You can see the 2 lines. Okay, there's one line right here, and there's one line right there. That tells me that this push rod has been bent. Now, if I have a bent push rod, what can that do? It has a big guide, so it's not a big deal there. The biggest problem is now, if it's bent, the height of this is different.